lecture, we will show some basic operations of NumPy array. The arithmetic operators. The most obvious are adding and multiplying an array by a scalar. These operations are element-wise, that is, the operators are applied only between corresponding elements. So A is an array with elements 0, 1, 2, 3. The A plus 4 will be an array with each element adding 4 from the original array. And similarly, this will create an array with each element is a multiplication of the original array multiplied with 2. And these operators can also be used between two arrays. So B is also an 4-element array with elements from 4, 5, 6, 7. Then A plus B will be the result of an array with 4 elements, and the element in the resulting array will be the addition of the elements with A and B. And similarly, for the multiplication case, will be element-wise, and the result will be a 4-element array. And moreover, these operators are also available for functions provided that the value returned is a NumPy array. For example, you can multiply the array by the sum or the square root of the elements of array B. They also, element-wise, assume A and B here have the same shape. So np.sum is the sum function of each element of B, and this is also an array with 4 elements. So A multiply this element will be also an 4-element array. Similarly, np.square root B will create an array with each element is the square root of B. So A multiply this part will create an 4-element array also. For multidimensional case, arithmetic operators continue to operate element-wise. So A is an 2-dimensional array with elements 0 to 8 and reshaped as 3 by 3 shape. And B is also a 3 by 3 shaped 2-dimensional array with all elements are 1. So A multiply B will be also a 3 by 3 2-dimensional array with the element is the production of each element from A with each element from B. So the matrix product in NumPy array is indicated by the dot function. This operation is not element-wise. That is, the result at each position is the sum of the products of each element of the corresponding row of the first matrix with the corresponding elements of the second matrix. So np.a, B is the multiplication, is the matrix multiplication from A to B. And alternative way to write the matrix product is to take the dot function as an object function of one of the two matrices. So we can write A dot B will create the same results as this one. And note that since the matrix product is not a cumulative operation, the order of the operands is important. So indeed, A matrix multiplication with B is not equal to B matrix multiplied with A. So this one and this one may not be the same. And the increment and decrement operators, to increase or decrease values, you have to use operators such as plus equal, minus equal, and multiply equal symbol. Instead of creating a new array with the results, they will reassign the results to the same array. So they will reassign back to the original array. So A is an array with 4 elements. Then A plus equal 1 will create an array and reassign back to the original array. So this will increment the original array. That's each element with 1. Similarly, A minus equal 4 will minus each element of A with 4, and this will multiply each element of array A with 4. And the universal functions, a universal function generally called ufunc is a function operating on an array in an element-by-element fashion. This means that it acts individually on each single element of the input array to generate a corresponding result in a new output array. So in the end, you obtain an array of the same size as input. There are many mathematical and trigonometric operations that meet this definition. For example, calculating the square root with the square root, the logarithm with the log, or sine with sine. We have seen sine and square root function before, and here is the log function. So we use np.log. We'll make a natural log function for each element of A. And aggregate functions perform an operation on a set of values of an array, for example, and produce a single result. Many functions of this kind are implemented within class and the array. So A is an array with 5 elements. So A.sum will get the summation of these 5 values, and A.min minimum will get the minimum value of these 5 values, and this will get the maximum value, and A.min will get the mean or average of these 5 values. A.std will get the standard deviation of these 5 values. We will show this statement in Anaconda Spider. So first we will see section 10, the NumPy library.py, this file, and import NumPy as np. Then we'll create this array. We'll show A. A is an array with from 0 to 3. The A plus 4 will be 4, 5, 6, 7. Is an A minus 2, 0, 2, 4, 6. And B is also 4 elements array. 4, 5, 6, 7. Then A plus B will be A multiply B, and np A will multiply with the sum function of B. Here A multiply with the square root of each element of B. The result both are also 4 elements array. And the multidimensional array operations, A is a 2-dimensional array. B is also a 2-dimensional array. Then A multiply B with 2-dimensional too. And the matrix product, then we'll see this is the product from A to B with the matrix product. You can use this formation the same, and we see this is the B multiply from B to A. The matrix multiplication is not the same as the first one. And increment and decrement operators, A is an array. Then we increment A with 1. Then we shoot again. A is now 1, 2, 3, 4. And we decrement with 1 for each element of A. Then we show A again. A is back to the original value now. And we create A again. 0, 1, 2, 3, A. Then A increments with 4. Can we run again? A is 4, 5, 6, 7 now. Then A with element-wise multiplication with 2. Can we shoot A again? Now 8, 10, 12, 14. And the universal function, create an array. Then A 1, 2, 3, 4. Then the square root of A. Then the logarithm of A. Then the sum function of A. And aggregation function. A is a 5-element array. 5-element array. Then the summation of these 5 values is 15. The minimum of these 5 values is 0.3. This is the maximum. This is the mean or average of these 5 values. And A.std is a standard deviation of this array.